And I said that, and I don't see any attendees. Pause the recording. All right, we have 2 attendees. We're going to get started with the assumption that more are coming. Is that okay with you, sir? All right.
Sure.
Thank you for coming today to today's sessions. This is the Minnesota GIS LAS Consortium Conference, and today we're going to be with Randy Knippel, who will be talking to us about emergency management. If anyone has any questions for Randy or for myself, please use the chat feature to be able to send those messages, those questions to us. That is going to be the simplest way to be able to get your questions answered. So with that being said, everything is being recorded. If you look later, we should be able to say that we have these available for viewing, but that's going to be later. Anyone has any questions about that, do not hesitate to email the organizers. And with that, I'm going to hand it off to Mr. Knippel.
Okay, thank you. I will share my screen. You see that okay?
Yes.
Okay. Well, welcome everybody. My name is Randy Knippel. I'm the GIS manager in Dakota County, but I'm also I am a member of the Geospatial Advisory Council Emergency Preparedness Committee, representing the effort of that committee to support the promotion of the U.S. national grid. Among other things, the committee does have a number of other initiatives. I've really been carrying the flag for the U.S. national grid for a number of years. I've given this presentation several times. If you have attended my presentations in the past, welcome again. Hopefully you'll get some additional nuggets to take with you. But this is an introduction to the U.S. national grid. I'm going to cover a number of things at a high level. I'll be crashing through some stuff pretty quickly. But my objective is to convince you that this is an important initiative and that you will be able to at least be able to communicate at a high level to your peers, customers, associates, why this is important. So with that, when I first started talking about the U.S. national grid and working with our emergency manager for talking about GIS, they really imagined that it did a lot of magical stuff. And we know that we can do a lot of great visualizations, 3D visualization and analysis and things like that. But if we think about GIS in terms of how we support emergency management, there's really this cycle that they go through. And the response part is when a GIS can be used for doing things like damage assessment. That's after an event occurs. The recovery portion is now how do you get things back to normal? So tracking status and resource deployment. Mitigation is how we learn from the last event and do some analysis to potentially have the impact of a similar event have less of an impact on our communities. And then preparation is helping with the planning so that we are better prepared for those events. But what we really need to think about is at this point here, I'm assuming you can see my pointer, but when an event occurs, we need to be able to provide we need to be able to rely on things that we can do very easily with a minimum amount of resources. We may not have electricity. We may have our own staff that are impacted by the event. And so we really need to think about what we can do with the least amount of resources the most effectively. And that's maps. Maps are the foundation of what we do with GIS. Just because we do a lot of interactive mapping does not mean that maps are no longer important. Having printed a certain number of printed maps available in an emergency is essential so that you can just open up a drawer, pull out a map, put it on a table without having to rely on electricity, computer network, database access, and so on. And then it's also teaching emergency managers and first responders how to use those maps. We take all this for granted, but it's something that really needs to be done for emergency managers and first responders. We've really adopted two primary formats for these maps. The maps on the left are 8.5 by 11, 1 inch equals 5,000, or 1 inch equals 600 feet, 1 to 5,000 scale. The larger map on the right is 22 by 24 inches and at a scale of 1 to 24,000 or 1 to 2,000 feet. And so those are two that work very well. The two formats are easily printed in a lot of cases, obviously 8.5 by 11, but even the larger format can be printed at a Kinko's FedEx or something like that. It's very easy to teach first responders, emergency managers, how to use these maps. First thing we do is point out that there's a grid on that map and that the grids are labeled. And we simply refer to a location on the map by reading right and then up. So we read right to grid 7.5, up to grid 5.6, and we can describe that square as 7.5.5.6. With a little bit of training, we can make people very comfortable with using that kind of terminology in relaying locations on maps. Similarly, the smaller maps at 1 inch equals 500 feet, 1 to 6,000 scale, represent the extents of one of those grid squares on the larger maps. So when we want to see more detail, we're able to go to a page in a book. The page is numbered the same as the grid square. So page 7456 will now have things like the fire hydrants, the addresses, the street names, school names, and things like that. Similarly, on those smaller maps, those smaller maps also have a grid, and now we can refer to a square on those maps by simply adding a digit. So reading right and then up, we can say that that square is called 741.565. And so all of these maps then form map books. So they're all pre-built. They can very easily be put together into a map book. The pages are all numbered sequentially using the grid squares as the naming convention. And then on one of those maps, we can further describe a location within a grid square by estimating the distance, reading right and then up, and adding a digit that represents that. So here we're looking at a location that can be described as 7413.5658. Well, all of this, it's very simple to teach this, but it's all part of a national grid system. And this is called the U.S. National Grid. The U.S. National Grid has been a national standard since 2001. It's adopted by federal agencies, the Federal Emergency Management Agency, Department of Homeland Security, National Geospatial Intelligence Agency, and the United States Geological Survey. The significance of that is that on the right, the first two are the emergency management side of the federal government, and the last two are the mapping side, geospatial side of the federal government. It's been adopted by several states, Florida, Missouri, North Carolina, others. Was adopted by Minnesota as a standard in 2009. It is, in fact, the military grid referencing system, which means that it's nothing new. It's been around since World War II. It was created so that it was easy for military to apply basic geospatial concepts of location referencing and projections using a very simple numbering system. So that means that it's also used by the National Guard, it's used by all NATO forces, and it is in fact UTM. Again, it's nothing new. It is nothing more than a simple nomenclature or a simple naming convention for UTM coordinates. So it's very straightforward, very easy to teach. Well, why do we need this? It makes a convenient layout for different map series and map layouts and map formats and so on. But what we really need is in a situation like this where we've lost all visual cues in the field. We don't know where the streets were. We can't see street signs. We can't see addresses. All we have is a continuous debris field. So how do we make sense out of that? Well, by using the grid and GPS, we can navigate to locations in the field, in this debris field, and use those locations with GPS to do things like search and rescue, as well as getting into things like debris cleanup. Plus, when we have the maps pre-created that show us where things like the churches, schools, city hall, fire stations, medical clinics, libraries, and so on were before this event occurred, we can navigate to those locations to even do more intelligent kinds of search and rescue, or perhaps recovery, if we're looking for specific things that were in the community, like at a pharmacy or something like that. Well, what about lat long? This is a question I get all the time. I've got GPS on my phone. Why can't it? It's giving me latitude, longitude. Why can't I use that? Well, it adds a certain level of confusion. The reason is it's not intuitive. It's degrees, minutes, and seconds. It's a base 60 system, which is simply not intuitive. There are also several formats: degrees, minutes, seconds, degrees, minutes, decimal minutes, degrees, decimal, degrees. And if you express it in one of those forms and it's interpreted in a different form, it could end up with a location that is 50 miles away from where you intend it to be. Also, longitude can be expressed as a positive or a negative number. If it's a negative number, they actually increase from right to left. You can also call it a west longitude or an east longitude, but again, it potentially adds another level of confusion. And then finally, how big is a degree? And the answer is, the world is round, it varies. At the equator, a degree is approximately 69 miles, both in latitude and longitude. But in Minnesota, in Dakota County, a degree of longitude is about 50 miles. And so degrees of longitude actually get smaller as you get towards the poles, and the degrees of latitude continue to be approximately 69 miles. Well, that means distance calculations are difficult. Now, certainly there are applications and websites out there that'll do that calculation for you, but it's important to be able to visualize this in your head and to be able to guesstimate some distances. What is the relationship of one location to another? And doing that using lat long is very difficult to do. Whereas US National Grid is in meters all the time, and it also applies a Mercator projection without anybody having to even know what that means. It essentially flattens the earth and gives you distance measurements on that from a map that relate very well to the distance measurements on the ground. Also, there is something called the National Search and Rescue Committee, NSARC, and they have created a land search and rescue addendum. And you will notice that they reference the US National Grid, and they say that is the primary location referencing system for land search and rescue responders. You will note that they also say that latitude, longitude is the secondary with a specific format of degrees, minutes, decimal minutes. So we have to think in terms of having pre-built maps. Pardon me. Where instead of my emergency manager coming to me when we have a tornado and saying, I need a map this big, covers these extents, can you make that map for me? Well, instead, we're going to use maps that already exist. And so these are more of a general purpose map that'll serve our needs, certainly at least in the early stages of an event, but potentially beyond that very well. But it's unlikely that an event is going to reside entirely on one map. Of course, here I have two maps that are actually adjacent to each other. Let's say the area of interest is actually split by that map. Well, it's very easy to give anybody instructions on how to make a larger map out of two smaller maps because they're the same scale, they're the same size, there is a certain amount of overlap between those maps. You can simply cut, tear, fold, whatever along one of those grid lines. They'll match up very well. And now you've got a larger map, and you can piece together as many maps as you need to make a very nice wall map very, very quickly and easily. So we have created those maps for the entire state of Minnesota. We've also been working with the state of Wisconsin, created maps for all of Wisconsin. We're working on Georgia. The maps exist for Iowa, all of that same 22 by 24, 1 to 24,000 scale format. which means that you can then go to a website, download those maps. They're all PDF files. Download the maps, put them on a thumb drive, and be able to carry them outside of the affected area to a printing service and print them out very easily. Or simply just have them available in your emergency go kit so that you will have very easy access to them in an emergency. Similarly, the smaller maps, one goes 500 feet, are easily assembled into a PDF map book. So it's a multi-page PDF file. All of the individual maps are created as individual PDF files, but then it's very easy to put those together into a multi-page PDF. So now I can simply create a website like this where City of Apple Valley's fire chief can go to this location, click on the hyperlink, and download their map book. Put it on a thumb drive again, I have it available. So these are all PDF maps and PDF map books. What that means is that we can automate the map production. It's very easy to do that in ArcMap with data-driven pages. ArcGIS Pro map has a similar capability called Map Series. Also, when we name these using the US National Grid, it creates a systematic naming convention, which means it's very easy to use things like Python scripting to pull those maps together. We can create a list of all of the maps for a specific city or any area of interest very easily using some kind of spatial index, generate a list of all the pages, use a Python script to pull those together into a multi-page PDF map book. Similarly, you essentially create map libraries where you have individual map pages that are transportable, standalone, it can be printed as needed, and anybody can do it. You don't need to be a GIS expert to be able to do that. A number of mobile apps are supporting the US National Grid. I encourage you to go look in your own app store to find them. You can just do a search for GPS, and then in those GPS applications, you'll find settings for either MGRS, Military Grid Referencing System, or USNG, US National Grid. They are effectively synonymous. Another interesting website, mappingsupport.com. Encourage you to check this out. This is a developer that has created an application that serves a variety of purposes, but I want to highlight it just because he's done a really good job of supporting the US National Grid. As you zoom in, you're able to see the grids labeled. Here we're seeing a single digit, and then getting down to 2 digits, which is a 1,000 meter grid. 3 digits is a 100-meter grid. 4 digits is a 10-meter grid. And these numbers will correspond to the coordinates at those even increments of 10 meters, 100 meters, 1,000 meters of UTM coordinates. So it all works together very nicely. And then he's got some other capabilities, clicking and seeing the location in a variety of formats. He has an app out there called Find Me SAR that also works very well. It's very easy for emergency managers to give somebody directions on how to use that to be able to define their location. There are a number of training opportunities available out there. They may not even say US National Grid. You can say this, you can see this one does, but you know, the military grid referencing system has really been used for backcountry trekking. It works very well with the USGS 1 to 24,000 scale quarter quadrangle maps. They are all US National Grid compliant with the way that they label the grids. And so really just looking around on the web for anything that's associated with backcountry trekking or military grid referencing system, and you'll find training available on that. Iowa Task Force 1 has created some really nice videos. You can do a Google search on this. You have to go through the Iowa Task Force 1 Urban Search and Rescue website to be able to get to those. It's not, they're on YouTube, but they are on a private channel, but you can find it through their website. Some very quick, here's an 8.5 minute video on effective search and rescue using the US National Grid. And they have a few other videos out there too. I encourage you to check those out. They can be very useful resources as you are trying to help others learn what this is all about. And again, it's really, if you go to Iowa Task Force 1, number 1 You'll find a link to those videos. USNGcenter.org is your definitive resource for anything and everything about the U.S. National Grid. This is really becoming a national resource through the work that we've done with the Geospatial Advisory Council Emergency Preparedness Committee. A lot of the resources that we've created and a lot of the initiatives that we've undertaken have really become a national resource. And so I encourage you to go check that out. We've also put some instructions and templates out there for creating map books with ArcMap. I have done the same with ArcGIS Pro. Just need to update the documentation to get the templates out there, but you can contact me. I'd be happy to share everything that I have. So there are instructions here on how to create these maps using ArcMap. Along with the U.S. National Grid, there are also something called emergency location markers. This has really been designed or devised in Minnesota through Shared Geo. Shared Geo is a local nonprofit that's been really working closely with us on promoting the U.S. National Grid. These are the blue signs that you can place on remote locations to help emergency responders find that location in an emergency situation. And it's actually a website app called usngapp.org, very simple, provides locations on your mobile device in the same form as those emergency location markers. And there is a native app called USNG app as well. You can find that in the App Store. I encourage you to check that out. My USNG is another app. It was created by Esri, and that has been embraced by Shared Geo. Also, they're taking over the support for that. So I encourage you to check those out. Esri's done a number of other things to support the U.S. National Grid. Again, doing Google searches, you can find some of this stuff. There are REST services that show that actually using National Geospatial Intelligence Agency REST service to display grid locations and so on. And there are a number of other tools that Esri has out there. I mentioned ArcGIS Pro. ArcGIS Pro does a very good job of creating gridded maps. There is a problem in ArcMap when trying to label grids along a grid zone junction between UTM zones, but ArcGIS Pro handles that situation very well and essentially allows you to create multiple grids in a map layout clipped at the UTM zone boundary, and it labels everything properly. So that's really good news. Esri's also created a grid overlay widget for Web App Builder. I encourage you to check that out. It's really pretty nice. You turn it on and you can adjust the colors and the different line and labeling characteristics. It's very nice little widget to add to your mobile applications for first responders. So momentum is building locally and nationally. You can see we've got maps for Minnesota. We've created maps for Wisconsin. I gave the same presentation to the Wisconsin Land Information Association earlier this year. And as a result of that, there are a number of counties that are interested in pursuing the U.S. National Grid, and was really able to just take the templates that I used for Minnesota and create all the maps for Wisconsin very easily. And then we've gone beyond that. State of Georgia, a number of counties are very actively pursuing U.S. National Grid. In fact, one county has implemented some 2,000 to 3,000 emergency location markers across their county on trails, and really you can find some good information from their website on what they've done and how they've done that as well. So I don't want you to use the National Grid. You know, this is something that is really incumbent on us as GIS professionals. You know, we really like creating interactive applications. We like doing a lot of analysis, spatial analysis and things like that. But this is one technique that's really in our toolbox that we need to use to promote and encourage the use of maps for emergency managers and first responders, as well as the general public in emergency situations. So I encourage you to get familiar with this stuff, be fluent in some of the basic terminology. It's really very simple. There are a lot of complexities behind it, but this makes that all much easier for the layperson to understand and to be able to use maps and GIS technology and GPS technology properly. So with that, I'd be happy to answer any questions. Is everybody still there?
I'm still here. I'm not seeing any questions pop up, but I do have a remark I'd like to make, Randy.
Sure.
I am a retired reconnaissance soldier.
Oh.
And when I was a private and I was first learning how to use the MGRS system, which, as you've explained, is the National Grid system as well, I was confused why this was not more of a standard across the country, because it was simple.
Yep.
It was easy to understand, and it was very, very easy to be able to teach the basic concepts, everything in units of 10, everything in these grids. And like you said earlier, if you want to make a continuous map, it's not that difficult with a pocket knife and some tape, and you've got a cohesive larger map.
Right.
So the fact that this existed for so long and is just now really starting to gain traction, it honestly kind of puzzles me, but excites me at the same time.
Yeah, your point is spot on, and this is very easy to sell with anybody that has military experience. And usually, when I'm giving training to first responders, emergency managers, you'll find people in the audience that have military experience, and those are your champions. They already get it, and just like you said, they wonder, how come we haven't been doing this all along,
And my experience too is that it's
on.
also very easy. I don't want people without military experience still be able to teach it, because it is a
right.
very, very simple system. And we do seem to have a question in the chat.
I see that. There's a question for the Minnesota maps that can be downloaded. How often are they updated? Well, that's me. I did just update them a year ago. And the whole idea was to make it as simple as possible. What I did is the previous maps were created with ArcMap. And what I wanted to do was create a new set with ArcGIS Pro, primarily because we needed to update them, but also because ArcGIS Pro does such a great job of representing the grids at the grid zone junction. That was just a dream come true. And really that came from working and talking with people at Esri, and they got the message, and they did a very good job on dealing with grids. It's very easy, simple. So how often is that going to be updated? Well, because the other thing was, I've been creating these maps just using the Esri base map. So Esri aerial photography base map and the streets base map, just to make it as easy as possible. Now, it'd be very easy to extend those using, I also do bring in some of the critical infrastructure layers from the NGA, USGS, and so on. So this will be an ongoing process. The maps were just updated earlier this year, so I don't see a reason to do that again. But it's really a matter of a few hours to create all the maps for the entire state. So what I'd like to do, what I intend to do, along with providing the templates for creating maps, anybody would be able to create those maps for Minnesota as well. Now, with the Emergency Preparedness Committee and the usngcenter.org, supported by Shared Geo, we have a place to publish all of those maps. We have an application that provides a spatial index to all the maps. So it's really just a matter of doing it. I would like to update the maps at least annually, but it's a matter of somebody doing it. It's not, nobody's doing it for us. Somebody needs to do it. And I think the Emergency Preparedness Committee of the Geospatial Advisory Council is a good organization to have that responsibility for Minnesota. So I think that works well. We certainly love to have you join us. And then we'll have a few more of us that might be able to create the maps. So thanks for the question.
Well, Randy, I'm working on my grad student program right now for data intelligence. So if you're looking for somebody, this is what I geek out over. I won't lie.
Oh, well, be happy to have you aboard. Send me an email or go to USNG Center. I think we actually have a place where you can sign up out there. Or send me an email. I'll get you going. We'd be happy to have you join us.
I might do that. Thank you.
All right.
Well, if anyone else has any questions, don't hesitate to throw them up. We have a surplus of time right now. So
yeah,
please.
I'm wondering if anybody is showing up for my presentation, because it was the second presentation on the agenda.
Right.
And the first presentation went away. And so I took the place of the first presentation. So, if I can just hang around. If somebody joins and was intending to see my presentation, I could do it again. But thanks everybody for joining me, and contact me if you have specific questions about U.S. National Grid. I'd be happy to work with you. You can find me in Google too.
We have a Q&A section. I just realized. Are there specific layers, roads, USNG grid maps must have on there?
Specific roads. I'm trying to find where am I? Oh, the Q&A. All right, I'm looking at that. Are there specific layers, roads, USNG grid map must have? USNG is a presentation standard for location referencing. As far as the content of the maps, there is no standard, and there's really nothing about the U.S. National Grid that specifically talks about maps in general. So, the conventions that we've created are really just trial and error. What works well, what doesn't work. There are other people have applied the U.S. National Grid. I mean, that's really fundamentally my message. Whatever map you are creating, put a grid on it, and it should be a UTM grid. Don't use county coordinates. Nobody knows what that is. State plane, so on. Put a UTM grid on it. It's good enough for associating GPS with a location on your map. You should also put degrees, minutes, decimal minutes. That's the convention. You never know what map might be used in an emergency situation. So put UTM grids on your maps. Esri will label them appropriately at different scales and things like that. So that's the most important thing. Beyond that, there are no standards for content of the map. As I said, I've been creating the maps at 1 to 24,000 scale, just using the Esri base maps, the aerial hybrid and the street maps. I mean, you can pick any base map. It just makes it real easy. I can make maps anywhere in the U.S. and they're all going to look similar. And I am also overlaying things like hospitals, schools, churches, things like that are available in the NGA REST services that are out there. So I don't know if you have a specific question about layers, if that answered your question. Okay, great. All right.
So I have a question for you, Randy.
Yeah.
What do you think is the biggest roadblock to this becoming a standard in the near term?
Well, it has to be embraced, and that's why I said I really think it's on us as geospatial professionals. We're the ones that are making the maps. We're the ones that people are coming to for doing, damage assessment and things like that. We need to have the conversation. And honestly, I think it's a door opener for us to start a conversation with the emergency managers and first responders to show them, here, we can make your map books for you very easily. And this is how you use them. And that's the starting point, because then that opens the door for doing all the interactive applications and databases and things like that we can do. You don't want to start with something that's so complex that they don't understand it. Start with something simple and then build on that. So somebody has to promote it. Somebody has to talk about this. And, it starts, if you don't start that conversation, they're going to make something up. They're going to use degrees, minutes, decimal minutes, or degrees, minutes, seconds, or degrees, decimal degrees. And they're going to think that it's going to work great until all of a sudden somebody misinterprets that. Somebody says degrees, minutes, decimal minutes, they forget to say minutes, and somebody interprets as degrees, decimal degrees, and it's a mess. So that's the role that we play as geospatial professionals in helping people understand how to use a map. We take it for granted. Don't assume that. What entity is the authority? They've all adopted it as a standard, which I think is as far as they can really go with it. You could say that Department of Defense is the authority because they have adopted it across all branches of the military. So all this is a civilian implementation of the military standard. That's really all this is. There isn't anybody that can dictate that it's used. Now, I would say though that some of this is getting threaded into some of the FEMA documentation, certainly in the FEMA training. We're seeing US National Grid now, as well as some of their requirements. When jurisdictions provide a list of their critical infrastructure, they're required to provide US National Grid locations with that as well. So that's good to see. I think a lot of that is going to happen just through the adoption of the standard at all levels of government. All right, so still have 3 attendees. Are there any other questions of you? And I would like to know if any of you have shown up thinking that you were going to see the second session. Okay, they're very, very quiet. All right, otherwise you said this is being recorded.
Yes.
Remains to be seen how that's going to be made available.
Yeah. Well, it looks like we're.
Everybody's dropping out now.
Yeah, I believe we're done, Randy. Thank you so much, Mr. Knipple. This has been very educational and very useful. I appreciate you having given us this block of instruction today.
You're welcome. I'd be happy to follow up with you too, Chair.
Yes, I'm going to pause this and then I have a couple questions for you kind of offline.